Nothing. Simple, right? Take everything away. Every atom, every photon, every particle, every whisper of energy. What's left? A void. Emptiness. The ultimate blank page. But ask yourself this: what does that emptiness do? What are its properties? What happens inside pure nothing? You'd say, nothing happens. That's the whole point. That's what makes it nothing. Wrong. Here's what should keep you awake tonight. We can build a perfect vacuum. We can strip away every atom, drain every photon, cool a space to within a fraction of a degree of absolute zero. We've done it. And when we look inside that emptiness with the most sensitive instruments ever built, instruments that can detect a single quantum of energy, we find that nothing is seething, bubbling, frothing with ghostly particles that appear from nowhere, exist for a billionth of a second, and vanish again. The vacuum is alive. Stephen Hawking put it with characteristic bluntness. The universe doesn't care whether you find this comfortable. Nothing isn't empty. Nothing is the most interesting something there is. Let me show you what I mean. The standard explanation of nothing is exactly what you'd expect. Nothing is the absence of something. It's what you get when you clear the stage. No matter, no energy, no space, no time. A perfect zero. A cosmic blank. You probably learned some version of this. It's not wrong exactly. It's just completely useless. Because here's what that answer skips over. We've actually looked at nothing, not philosophically, not as a thought experiment, physically, with instruments. We've created the most perfect vacuums achievable by human technology, and we've examined what's inside them at scale smaller than an atom. And what we found broke the question. It has rules. It behaves in ways so strange that 3 generations of physicists have argued about what it means. And they still haven't stopped. Hawking saw something in this that most people miss entirely. The question everyone asks, why is there something rather than nothing, assumes that nothing is the natural state, the default, the thing that should exist unless something intervenes. What if that assumption is backwards? Let me start somewhere you can actually see it. Start with something you can actually do. Take a glass jar, seal it tight. Now pump out the air. Every molecule of nitrogen, oxygen, carbon dioxide gone. Use the best vacuum pump you can find. Get it down to 1/1,000,000th of atmospheric pressure, then 1 billionth, then cool it. Cool it to within a fraction of a degree of absolute zero, 0.0101 Kelvin, almost the coldest anything can possibly be. Now look inside. You'd expect silence, stillness, the purest emptiness achievable by human engineering. A jar of nothing. Stop and think about that for a second. What should be in that jar? Your instinct says, nothing. That's the whole point. We removed everything. There is nothing left to find. But here's what's actually happening inside that jar. At scales far smaller than an atom, at distances of 10 to the negative 35 meters, a scale so small that if an atom were the size of the observable universe, the scale would be the size of a tree. The emptiness is churning. Pairs of particles are flickering into existence. An electron and its antimatter twin, a positron, materialize from nowhere. They exist for a duration so short no clock could ever measure it. Then they collide, annihilate each other, and vanish. Then it happens again, and again, and again. Trillions upon trillions of times per second, in every cubic centimeter of that empty jar. These are called virtual particles, and that name is misleading. It makes them sound imaginary, hypothetical. They're not. They're real enough to be measured, real enough to change the behavior of atoms, real enough that without them, the equations that describe reality fall apart. Your jar of nothing is a blizzard of creation and destruction, happening faster than anything you can imagine, at scales too small to see. That's not nothing. That's the busiest place in the universe. But that raises a question. Where are these particles coming from? You removed everything. There's no energy source, no fuel, no cause. So how is the vacuum creating something from nothing? Here's the first piece. In 1927, Werner Heisenberg discovered something that sounds like a technicality, but is actually one of the most profound statements ever made about reality. He showed that you cannot simultaneously know both the exact position and the exact momentum of a particle, not because your instruments are bad, Not because you're not trying hard enough, because the universe itself hasn't decided yet. This is the Heisenberg Uncertainty Principle. And it doesn't just apply to particles you can see. It applies to empty space. Think about what that means. To have true nothing, perfect, absolute emptiness, you'd need to know with complete certainty that a given region of space contains exactly zero energy and exactly zero particles. You'd need perfect knowledge of both the energy and the time duration of that emptiness. But the uncertainty principle says you can't have that. You cannot pin down energy and time simultaneously with perfect precision. The more precisely you define one, the more wildly the other fluctuates. So perfect emptiness would require perfect knowledge, and perfect knowledge is forbidden. The universe literally cannot be empty. Not chooses not to be, cannot. Laws of physics prohibit it in the same way they prohibit traveling faster than light. Emptiness isn't just rare, it's illegal. Heisenberg didn't think he was answering an ancient philosophical question. He was doing math. But the math said something the philosophers never expected. Nothing is unstable. But wait, if the vacuum can't be truly empty, if particles are constantly flickering in and out, where is the energy coming from? These particles are real. They have mass, they have charge. Creating them requires energy. And you can't just conjure energy from nowhere, can you? Here's where it gets strange. You'd expect the universe to have strict accounting. Energy in equals energy out. Nothing created, nothing destroyed. Conservation of energy, the most sacred law in physics. And it does obey that law perfectly. But it exploits a loophole that sounds like it shouldn't be legal. The uncertainty principle doesn't just say you can't measure energy and time precisely. It says that energy itself can fluctuate, as long as it fluctuates fast enough. Here's the thing that should bother you. A particle can borrow energy from the vacuum. It can pop into existence with borrowed energy, exist for a brief moment, and then pay it back by annihilating. The more energy it borrows, the faster it must repay. Borrow a little energy, you get a little time. Borrow a lot, you get almost none. This isn't a metaphor. This isn't poetry. This is measured reality. In 1948, a Dutch physicist named Hendrik Casimir predicted something remarkable. If virtual particles are real, if the vacuum truly seethes with these fluctuations, then two metal plates placed very close together in a vacuum should experience immeasurable force. The plates would limit which virtual particles could exist between them, creating an imbalance. The vacuum itself would push the plates together. This experiment has been done. The force is real. It's been measured to extraordinary precision. It's called the Casimir Effect, and it's one of the most direct pieces of evidence that nothing is full of something. The vacuum is not empty. It's a roiling ocean of energy, borrowing and repaying on timescales so short, they make a femtosecond look like an ice age. Think about what that means. Every point in empty space, every cubic centimeter of the void between galaxies, every gap between atoms in your body is a furious economy of creation and destruction. Particles appearing, existing for an instant, too brief to name, vanishing. The books always balance, but the transactions never stop. Now, here's where Hawking saw something everyone else almost missed. If virtual particles can borrow energy and pay it back, if the vacuum can create something temporarily, what happens when the payback gets interrupted? What happens when something prevents the debt from being repaid? Now we're at the core. Picture a virtual particle pair appearing at the edge of a black hole. One particle inside the event horizon, one outside. Normally they'd collide and annihilate, paying back the borrowed energy. But the black hole captures one. The other escapes into the universe. A virtual particle just became real. Energy borrowed from the vacuum was never repaid. The black hole loses a tiny amount of mass to compensate. This is Hawking radiation, Stephen Hawking's most famous prediction. The vacuum's bookkeeping error at the edge of a black hole. This should break your brain. The nothing of empty space, under the right conditions, produces real, permanent, measurable particles. Not temporarily, permanently. The vacuum creates. Now scale this up, scale it all the way up. Hawking and others asked the most dangerous question in physics. Could the entire universe be the ultimate bookkeeping trick? Here's the calculation that changes everything. Matter has positive energy. That's obvious. Stars, planets, you all, positive energy. But gravity has negative energy. The gravitational attraction between all the matter in the universe represents an enormous amount of negative energy. When you add them together, all the positive energy of all the matter and radiation in the cosmos, plus all the negative energy of gravity, the total appears to be approximately zero. The universe's net energy may be nothing. And if the total energy is zero, then the entire cosmos didn't require any net energy to create. It didn't violate conservation of energy. It didn't need a deposit. The positive and the negative cancel perfectly, like a loan that was always exactly balanced. Something from nothing isn't miraculous. It's bookkeeping. In your everyday experience, nothing is simple. It's the default state of the universe. It's what was here before everything else. It's the blank canvas, the silence before the symphony, the empty stage before the actors arrive. Nothing is easy. Something is the thing that requires explanation, completely backwards. Pause. Nothing is not empty. Nothing is not simple. Nothing is not the default. Nothing is the most energetic, violent, creative environment in existence. It is an unstable, seething, frothing chaos of virtual particles and energy fluctuations that cannot stop producing something, because the laws of physics will not allow it to be still. Let me prove it to you. The Casimir Effect. Two metal plates in a vacuum pushed together by the pressure of virtual particles. Measured. Confirmed. Real. Hawking radiation. Virtual particles at the edge of a black hole, torn apart, becoming permanent. Predicted in 1974. Supported by every theoretical framework we have. The mathematics is exact. The Lamb shift. The energy levels of hydrogen atoms are slightly different from what classical theory predicts, because virtual particles in the vacuum interact with the electron. Measured by Willis Lamb in 1947 to a precision that won him the Nobel Prize. Accurate to 11 decimal places. The vacuum is not empty, we've measured its contents. Think about what this means. Every empty room you've ever walked into was full. Every gap between stars teeming, every void, every vacuum, every silence, a roaring ocean of creation at scales too small to see. Pause. And the grandest implication of all, the universe itself, all of space-time, all matter, all energy, every galaxy and photon and atom may have emerged from this nothing, not from something, not from a cause, from the fundamental instability of emptiness itself. The question, why is there something rather than nothing, assumes nothing is stable, assumes nothing is stable, assumes nothing is natural, assumes something needs an explanation. Hawking flipped it with the precision of a scalpel. Nothing is unstable, something is inevitable. The universe didn't need a cause, any more than a virtual particle needs permission. It needed nothing, literally nothing, because nothing is the one thing that cannot persist. This isn't speculation. This isn't philosophy dressed up in equations. This is what the equations say when you take them seriously. This is the measured, tested, Nobel Prize-winning structure of the vacuum. Nothing isn't the absence of everything. Nothing is the potential for everything. And that potential is so fierce, so restless, so fundamentally incapable of remaining empty, that it created a universe just to discharge itself. That's not a metaphor. That's physics. Now here's what people miss when they learn just about the vacuum. This isn't an isolated curiosity. This isn't some quirk at the edge of physics that only matters in laboratories. The instability of nothing touches everything. The same restless vacuum that produces virtual particles also drives every force you've ever felt. Every push, every pull, every attraction and repulsion between particles, electromagnetism, the strong nuclear force, the weak nuclear force, all of them are mediated by virtual particles. When two electrons repel each other, they're exchanging virtual photons. The vacuum isn't a backdrop to forces, it's the medium to which forces operate. Without the seething nothing, there are no forces. Without forces, there is no matter. Without matter, there is no you. Creates Hawking radiation at the edge of black holes. Virtual particles become real. The vacuum's instability slowly evaporates the most powerful objects in the universe. Given enough time, and we're talking 10 to the 67th years and beyond, every black hole will dissolve into the nothing that made it. Nothing creates, nothing destroys. Same mechanism. Powers the expansion of the universe itself. Dark energy, the mysterious force accelerating cosmic expansion, appears to be the energy of the vacuum. The nothing between galaxies is pushing them apart. The emptiness as pressure. It acts on the fabric of space-time. 70% of the total energy content of the universe is vacuum energy. 70% of everything is the energy of nothing. May have triggered cosmic inflation. In the first fraction of a second after the Big Bang, the universe expanded faster than light, driven, we believe, by the energy of a vacuum state. Thus, it didn't just create the universe, it inflated it to cosmic scale in 10 to the negative 36 seconds. The same principle, every time, what looks like many different phenomena, forces, radiation, dark energy. The birth of the cosmos is actually one thing wearing different mass. The quantum vacuum expressing its fundamental instability in every way physics allows. You're not separate from this. Right now, inside every atom of your body, virtual particles are flickering in and out of existence. The electrons in your cells are interacting with the vacuum every instant. The nothing inside you is doing exactly what the nothing between galaxies is doing. You are built from the instability of emptiness. That's not metaphor. That's not poetry. That's what you are. So, what is nothing? You started with a simple answer. Nothing is the absence of everything, the void, the blank, the default state of reality. Now you know that answer is backwards. Nothing is a quantum storm, a seething instability of energy and potential that cannot remain empty because the laws of the universe forbid perfect stillness. It creates particles. It mediates forces, it drives the expansion of space-time, and it may have produced the entire cosmos without needing a single joule of net energy to do it. The question, why is there something rather than nothing, turns out to contain its own answer. There is something because nothing is impossible. Emptiness is not the natural state. Fullness is. Creation is. The vacuum doesn't rest. It can't. But understanding this isn't just about the vacuum. It's about the nature of knowledge itself. For 2,000 years nothing was a philosophical question. Aristotle debated it. Theologians argued over it. Philosophers wrote volumes about the void. And for all that time nobody could test it. Nobody could look. Then we built the instruments. We created the vacuums. We measured the forces. We did the math. And in less than a century we answered a question that had haunted humanity for millennia. Not with speculation, with measurement, with prediction confirmed by experiment to 11 decimal places. The fact that we can do this, that a species of evolved primates on a small rock orbiting an ordinary star can peer into the vacuum and understand its structure, Hawking found is the most remarkable thing of all. More remarkable than the vacuum itself. The universe is comprehensible. It didn't have to be, but it is. That's what nothing really is. Not absence, not void, not emptiness. Its potential so dense it cannot help but become something. Not metaphysics, not mystery. Physics, truth. If this journey into the heart of nothing changed how you see the empty space around you, subscribe. Not because I'm asking nicely, because the next one goes deeper. Share this with someone who still thinks the vacuum is just emptiness. Let them sit with that for a while. Every gap, every void, every silence they've ever experienced. Full, seething, alive. Now here's what I want from you. What other simple concept do you think is hiding this kind of depth, time, gravity, consciousness, color? Tell me in the comments. Because I've learned something making these videos. The questions that sound the simplest, the ones a child would ask, the ones adults stopped asking because they assumed the answer was obvious. Those are always the ones with the strangest, most reality-breaking answers, and nothing proves that better than nothing.